In this video, we're going to celebrate the coming together of two very special individuals, the two halves of the engine case. In the upcoming video, I'm going to show you how I put together the short block with those two pieces and many more. Enjoy. I wanted to do a quick recap on the beginning of day 5. Yep, day 5. It's taken me 4 days so far just to get to where I am, where the crankshaft is assembled. I think for anybody who's doing this for the first time, don't underestimate the time required for cleaning. That's where I put most of my time thus far, just making sure everything is totally spick and span. So where I am right now is the one half of the case is on the engine stand right here. And I've put a plastic bag over it just to make sure there's no dust on it. The other half of the case is over there in another plastic bag, and I've meticulously cleaned that as well. So after putting in the hours and hours and hours of cleaning, I wanted to make sure it stayed clean, so that's why the plastic bag's over it. And then behind it is the crankshaft assembly with the con rods on it, also in a plastic bag. So those are sitting there ready to go on a clean table and ready to assemble. I recently got a bunch of the additional parts I need for this assembly, and so they're laid out here. Now, a lot of those little baggies are from Pelican Parts hardware kit that you can buy. And I didn't exactly know what's in it. They don't list it on the website. I don't know if it's worth it yet. I will keep you posted through this build, whether or not it's worth buying. But I figured it's not cheap. It's like 260 bucks. Hopefully I need all those, particularly the unique fasteners. But I think a lot of my old fasteners I can reuse, and I'll assess that as I go. Another tip, if you're buying stuff from Pelican for this project, is if you are a Porsche Club of America member, you can do one order per year where you get 10% off. And so what I did is I saved a big list of parts that I purchased in one big order, and certainly not all of them on this table. And when you take 10% off, the price is pretty competitive compared to anywhere else you can buy it. So just food for thought if you're a PCA member already. And also a PCA membership is 40 bucks. And if you're placing, a $400 order, there you go, you save that money right there. And then the other thing I have to do is run some errands to be able to make these parts. These are the little brackets that hold up the con rods and the timing chain, when you assemble the two block halves together. In Dempsey's book, he says that you can buy this kit. I looked it up, it's like 70 bucks, so I'm just gonna go to Home Depot and buy those things. Unfortunately, Home Depot didn't have any 1-inch wide sheet strips to make these tools, but what kind of engineer would I be without some sheet metal laying around? So with a little bit of cutting and welding and bending, voila. This is a pretty big day in the engine rebuild, because for the past many days I've been basically prepping to get things into the engine case, and finally today we can start assembling the short block. I want to just touch on what's gone into this over the last actually few days. So over here is a bunch of parts that I took apart from the old engine over a year ago, and I labeled all of them in little plastic bags. And this is not only important for remembering what goes where, but also remembering what fasteners go with what. So like, here's the thermostat, and you can see these little nuts and little washers go with this thermostat, and that's gonna help me match those with new case hardware that I've ordered that I can put together with this. So I've laid out all the parts for the full block assembly, the case assembly, and here are all the seals and the new fasteners. It's basically this is old, new stuff, this is old stuff. Then over there I have the crankshaft in one half of the case, and over here I have the other half of the case already in the engine stand. So today we're going to start slapping that together. Now I mentioned that it's been over a year since I took apart the engine. During that time, my wife and I actually took a sabbatical and lived in Italy, and also did a 20,000 mile road trip around Europe, and this came with us. And so you can see all the stickers on the 964. That's a longer story for another time, but That was quite an adventure. When I put the intermediate shaft bearings into the block, they're quite tight. And I couldn't just push them down with my hand like I had with the conrod bearings. So what I ended up doing is taking two hammers, and one with a really soft rubber end, just molded rubber, and just really gently tapping with a dead blow hammer just to seat the bearing. And so that makes sure that the bearing is completely seated in the right position. So when I lay the intermediate shaft in here, it's not wonky and out of place, and that it can actually lie with the block as it's supposed to be. I just want to reiterate why you have to clean the heck out of all your parts. So this intermediate shaft already went through the parts cleaner, which has a filtered outlet where it sprays the cleaning agent, the mineral spirits. And just, you know, before I put it in the block one last time, I ran some brake cleaner through it, and just check this out, what flows out the bottom. Look at all that gunk. I don't know if you can see it there, coming out on the table. Watch this. You can still see gunk coming out. Oh my God. So all of this, I think it's all grease. It's all coming apart like as I rub my finger in it, but still, it's a risk of chunks of stuff getting caught in the bearing journals and really screwing up those journals and scratching them. So it's so important to really clean like crazy before you assemble the engine. Okay, here's the first thing that I'm going to put in the case, which is the oil pump and the intermediate shaft. So this should be able to slot in to the two bearings that I just lubricated, and the oil pump should fit over these threaded posts. Okay, I think that's seated. Nope, there we go. Woo, and it turns perfectly, turns easily. Oh, that feels pretty good. Nice and smooth, bearing, no hang-ups in the bearings. I think that's exactly how it's supposed to feel. All right. I'm now going to install the seal for the crankshaft on the pulley side. And so I'm going to apply a little bit of all the dust out. This is a constant battle against dust. So apply a little bit of sealant on the surface where the seal is going to mate with this pulley bearing. And spread that out. Just my finger. And the idea here is that once the bearing gets pushed into this, this will fill any remaining little gaps where oil could leak out. And now, push it in. Actually, I can push it in by hand. All right. Give it a little tap with this rubber mallet. That is good to go. Now it's time to put on the main crankshaft seal, and like every other step in this process, you clean it first. I've just cleaned off the end of the crankshaft really well, although I see a few flecks of dust. Just fibers from the clean wipes, which are supposed to be non-fiber or non-pill producing. Now I have to put a thin layer of assembly lube on, and then I can slip the seal hopefully right on without much effort. So get some assembly lube all over the surface, the sealing surface. It's amazing to me how this could have run, this engine had about 120 something thousand miles on it when I tore it down. And it's amazing that it could run for that long, and the seal really doesn't wear at all into the surface. The sealing surface is totally smooth still. You can see a line where the old seal was laying, but overall it's in great shape. Again, lubrication and hardness. The seal's a lot softer than the steel of the crankshaft. Okay, so this end out, and this is actually kind of cool too. This is what's called a lip seal. So if you look at the seal, you can see it has a lip on it right here. And with pressure, high pressure on this side, it actually tries to clamp the seal down even harder and would try to roll the lip to push on the crankshaft harder. So it kind of self-seals even more under higher pressure. Also, there's a spring around it to keep a good clamping force. So I can hopefully just press this on. Oh, there we go. I don't know how far in it's supposed to go. I'll know when I put it in the case. But that is ready to go. Nice. So I'm right about to drop the crankshaft in to the block. I have prepared with assembly lube, covered all the surfaces of the bearings. I've put gasket sealer on where the main crankshaft seal is going to go. The crankshaft's ready. It's got the seal on one end, the flywheel end. It's got the nose bearing and the seal on the other end. And so I should be able to just pick it up by the con rods and then drop it in. Okay, full disclosure, I had to take the crankshaft out again and re-lubricate all the bearings, put new sealing silicone in for the seal at the end, because I forgot to put the O-ring on the end of the crankshaft before I put it in before. I don't think Wayne Dempsey addresses that specifically in his book. So as a word of caution, try to remember that when you're doing this. So let's try this again and drop this in again. I hope I got all the sealing material off well enough. And hopefully second time's a charm here. So lower this down, try to get that con rod out of the way. As I did before, dangle it. There we go. And oh, there we go. It just dropped in. Oh my God, that's a lot of work. What makes this particularly challenging is, one, you're fighting against timing of the sealant. Two, if you have to take the crankshaft out again, all the bearings come out with it. They just pop right out. And oh, you have to clean them again, put them back in. It's a pain. So for those of you trying this at home, remember this O-ring right here on the nose bearing, because it's a real pain in the butt to get it out and then put it in again. I think I'm okay. I've got some silicone sealant on the seal that'll get mated with the case. I'm going to try to take that off actually with the with brake clean. But I think otherwise we're okay. The O-ring looks good, and it's clamping. The nose bearing is seated. Let's see if this moves. Yeah, everything seems to move okay. I can turn those. Good. Whew, man, that is tricky to do. So if you can, do it once, not twice. It turned out to be third time was the charm. The eagle-eyed viewer of the last time I tried to put it in the crankshaft might have realized or seen that I had 4 conrods sticking up and only 2 sticking down, which for a flat 6 doesn't exactly work out. So I had to lift up the nose bearing again. Fortunately, I realized this time that I could lift it up and pop the bearings down, the inserts down, to reseat them, and I didn't have to take the crankshaft totally out. I did have to clean off some more sealant on the seal again, but I think it's okay. It's still, you know, it still moves freely, so it doesn't seem like there's any, at least what I can feel, binding. I have really meticulously cleaned it every time I've touched it, so I think it's clean. Hopefully there's no issues. Hopefully I don't have to take it out again. It's just such a nightmare with the assembly lube because it gets everywhere and you have to clean off all the sealing surfaces again. But I think it's good to go. The next thing I need to put in the crankcase is the oil pump and the intermediate shaft. And the intermediate shaft is what drives the 2 chains that go to the cams. I've put in the seal, which is right here, that seals the bottom of the pump with a block. And I've put the 2 chains on the intermediary shaft right here, or intermediate shaft. I can't remember exactly what it's called. And so now I have to put this in there, which I think again is going to be a bit of a balancing act. So this chain is going to stay up. I'm going to try to hold that. That's going to point upwards when it goes in the block. Actually, I think I can hold on to this with the chain if I don't let the shaft slide out. Yeah, that'll work fine. Okay, so now I need to drop this down like so. And that gear has to mesh. I think come back a little bit. And then the pump has to drop down and seat. I think it just did it. All right. Let that hang down a little bit. I think we are good. So I should be able to turn everything together. Yeah, look at that. Cool. And the pump looks seated. I think it will get, yeah, it'll get completely seated once I bolt down these 3 bolts. But it looks like everything can move freely and there's no binding. All right, hopefully I got this one in on the first shot, unlike the last one. Well, let's start with a quick recap of what is now day 7 of this engine rebuild. So last night I left everything covered up. So there is the left engine case half, there's the right on the engine stand, which has the crankshaft and the oil pump and the intermediate shaft installed. And today what I'm going to be doing is mating these 2 halves. When I do that, I have a pretty short amount of time to do it before the sealant dries. So as soon as the 2 halves touch and the gasketing sealant gets air blocked off from it, it starts to cure, and you have about 45 minutes. So to get everything ready so I can do that quickly, I'm going to lay it all out on this oil pan. Some of the major components here are the studs that clamp the 2 sides of the case together. So I need to clean all those, get the O-rings ready that seal them. And then there's something like 23 or 25 more nuts that have to go around the perimeter of the case. So I want to make sure those are all ready. And so with that all set, I can clamp the two case halves together and then quickly put in all the fasteners and clamp it tight before the sealant dries. After many more hours of preparation, the engine case is just about ready to go together. On this half of the case, I've got the spacers put in that I made that are keeping the con rods upright and the timing chain upright, so when I place the other case half on, they don't conflict. I've gone through and cleaned all the surfaces yet again, where I'm going to apply the sealant, which is the next big task. That's important because, one, you don't want to get any gunk in there, and two, when you put the case halves together, you have about 45 minutes before it cures. And that's why all the rest of this stuff is out here to be ready once the case halves mate together. So over here is all the through bolts that have all been cleaned with all the O-rings prepped and ready to go on once they go through the case halves. Here's the other hardware that goes around the perimeter of the case, where I have the nuts and washers all ready to go. And then over here, I've got the other case half. I've put the assembly lube on all the bearings, and I have both torque wrenches I need to do this job set and ready at the right torque values with the right sockets. And the reason, again, for all this prep is to move fast once the case halves are together, because I have a very short amount of time before the sealant dries. I'm ready to start spreading the Loctite 574 sealant all over the case. Everything's clean. I think I'm ready to start. I'm going to go from the inside out and hopefully not touch anything and screw it up. I just tried a little test bit on the metal drip pan over there, and it comes out pretty fine, so I can just do a little bit at a time. What's nice about this too is it only dries in the absence of air. So I really have as much time as I need to spread it all over the block and get it perfect before I put the two case halves together. At that point, then the clock starts ticking. So here we go. I'm going to try in an easy open area first. In Dempsey's book, he says, apply it pretty liberally. Now, I don't want to get it in any bearing surfaces, of course, but I can spread a pretty thick film and just kind of dab it around. These surfaces close to the bearings actually don't need sealing. I think Wayne Dempsey recommends you apply it here just for uniform clamping pressure, although most of the sealant's going to get squeezed down anyway. There should be very little in the gaps, but if clamping pressure does matter, this will help. Make sure it's uniform. Here we are, ready to mate the two case halves. You can see the orange sealing compound on all the mating surfaces. This took many hours to brush on because you have to be particularly careful right where the bearing material meets the case, and you don't want to mix assembly lube with the sealing agent. So this was, I think, quite a piece of artwork if you consider coloring books artwork and painting within the lines. So this side is ready to go. The other side of the case is right there, also ready to go. I've applied the sealant for the flywheel side of the crankshaft seal, and here we go. I think it's ready to mate. So I'm going to put this down. And wish me luck. I've checked and double checked and triple checked everything. The chain and the 3 con rods are in the right place. The seals are on the oil pump. The silicone sealant's on the crankshaft journal. Aha! I almost forgot to put assembly lube on the intermediate shaft bearings. This is why you do triple, quadruple, quintuple checks. One last triple check. I've got all the seals on the oil pump. I've covered every sealing surface in the block. Check one more time. I think the con rods are in the right position. I've got assembly lube on all the bearings on the other case half. I've got the silicone sealant for the crankshaft seal on the flywheel side. And I've got all my fasteners laid out right here next to me, which I can put in very quickly. So here we go. I think I'm finally ready. Try not to grab anything or I'd get dirty. Okay, here we go. First, the chain, and then the crankshaft. Align those rods. Whoa, touchdown. All right, so now I should be able to just whack this with a mallet a little bit. And the case is mated. Has to squeeze tighter on this side. But I think that's going to squeeze down. I think that's partially because of the seals on the oil pump. But those look like they seated okay. So we'll see when we tighten it down. Okay. So the next part is putting in all the through bolts. And let's see. Oh, I need to check if the crankshaft turns too. Let's take these out. Easier said than done. There we go. The clock is ticking too. I should take note of the time. Got 45 minutes. It's 6:30 now. The chain there. So we should be able to turn everything. Yep, everything's turning okay. That's a good sign. All right, through bolt time. Here's some black RTV sealant that I'm putting around the O-rings. Try not to get tons of it on my hands. I guess it doesn't really matter if I do. And put a liberal helping on the outside. Great. And let's see, I'll drop that in, I guess right here.
cool. I'm gonna do this a bunch more times. Recap time. So I just spent the last hour torquing down all the bolts in this thing, and there's a lot of them. These big ones by the cylinders are the through bolts, and those clamp the main bearings, so the clamping force on those is very important, not too much, not too little. And then all around the case, there's these smaller bolts, M8 bolts, or nuts rather, on threaded posts that go all the way around, and there's 20 something of them. But the clamping went well. You can see that the crank moves quite easily. If I put my finger in here, there we go, I'm turning the crank and push it back. So no feeling of resistance or anything. Despite how much silicone sealer I got on my hands, I managed to get some on the case in the right spot as well. I gotta clean all that up, but I did get silicone around all the O-rings on both sides of the bolt heads and the nuts. And I think probably most critically, if you look around the case, you can see the squeeze out of the case seal between the two halves, that orange line. So that's exactly what I wanted to see. Here's the top side of the case, all the way around, just a little bit of squeezing out. And it's quite uniform all the way around. So I'm really happy with that. I think that's exactly how it's supposed to look. And it looks like I got a good clamp all the way around. And also the seal on the crankshaft looks like it seated pretty well when I put the case halves together. All in all, I'm pretty happy with this. And I think that's about as good as I could have hoped it went for my first time ever doing this. So now it's just cleaning up all the silicone, and then I think I'm gonna call it a night. This is a long day, but a good feat and a good feeling of accomplishment. It's been a week, and it's now the weekend again, so I'm back in the garage working on the case rebuild. The next step I have to do is go back to all of these factory plugs. Like here is one, and down here is another. And these are plugs pressed into the case that need to be resealed. The factory would put a coating of an epoxy type substance over it, just as another barrier, so there's to protect against oil leakage. So what I'm going to do next is take some JB Weld. Well, before I do that, wire brush the surfaces where the epoxy is going to go, then take some JB Weld and just kind of coat it on liberally to provide that extra sealing protection. One thing to note as you seal up all the plugs is that as you scrape them down with a wire brush, it creates some dust. And I waited to mate the case halves. This is different than what Wayne Dempsey recommends in his book. He recommends to do this before you mate the case halves, but I waited in order to make sure there was no exposed bearings in the main crankcase that could get any of the dust or metal particles on them from this brushing action. So I would personally recommend that if you are doing this yourself. There's a lot of plugs, and you can see particularly on the bell housing side, there's a plug here, there's a plug down here. Those are all really close to the crankshaft, so if you did this when the case is separated and you have the main crankshaft bearings exposed, you could get some dust on them. I guess alternatively you could do this way before you clean the rest of the case. That could also be a good time when the case halves are separated. But I'm finding this pretty good in that when the case is bolted together, I'm cleaning here, but the bearings are way up here at the top. So it's pretty far separated. I'm being mindful of the oil passages here too, and I'll clean those out again before I plug them up. After I wire brushed all of the plugs, I've cleaned them off with brake clean, and I'm just lathering on a good dab of JB Weld as a secondary sealing protection. I'm trying to get it into the crack between the plug and the case. And put it on somewhat thick, but not too thick so that it drips overnight. Because it takes quite a few hours to cure. It's something like 4 to 6 hours. A week has gone by, and I wanted to give a short recap of what I'm up to now, this next weekend. So last week, I got the short block together, and I am getting ready right now to put the head studs in. So the head studs are right here, and these are what clamps the heads to the block and squeezes the cylinder. So these are really pretty race studs made by ARP that can take a ton of power and are super strong. And so what I'm doing right now with the short block is I'm prepping it for the studs. So what this entails is I'm first going through all the holes where the head studs are going to go in with a Q-tip. You know, first filling them up, kind of blowing them out with brake cleaner, and then cleaning them out with a Q-tip to get them nice and clean. Another thing I'm doing is I noticed that the surface here on the cylinders, or where the jug is going to mate with the block, this is where a copper seal is going to go. This is where a spacer seal goes in to set the right deck height of the engine in order to make sure the piston doesn't hit the head when it goes all the way up. So what I've done is just very carefully been taking off any gunk. So this is a clean one that I've done, and then next to it you can see, like up here, there's just some schmutz that's left over, and over here, just kind of cleaning that all up so it's a really flat and smooth and clean surface. Now when I do that, obviously some dust is made, and I don't want that to get in the engine or anything, so I'm doing it very carefully. I'm not blowing dust in, and a little dust collects in the bottom of the barrel, and so I'm wiping that off after I sand and getting all that gunk out there. Also what I did is I put painter's tape over the small end of all the connecting rods, just because there is a bearing surface here that I will clean eventually and put assembly lube on in order to put the wrist pin through to connect the piston to. So I want to keep that all clean, and so just while I'm cleaning and there's dust being generated, I'm keeping those covered up. And I'm being very careful to, after I sand, to clean out, just to minimize any dirt that's pushed inside. Now I certainly need to be vigilant about getting dust in the engine, because you don't want to get it into a bearing or clog anything up. But what is good about right now is that the conrod bearings and the main bearings on the crankshaft are closed. So they're all bolted up, and there's assembly lube in there, so the chance of getting dust in the bearing is pretty low. And then when the engine first starts, oil will be pushed in to the bearing and flush the assembly lube out. So any particulates on the outside of the bearing that I'm generating should be flushed out and flushed into the bottom of the sump to be sucked up by the oil pump. Now I also don't want a lot of junk getting sucked through the oil pump, so that's why I still need to be careful. But I don't have to be as meticulous as I was when the block was totally open, but still have to be pretty careful. And I think when in doubt, keep it clean and try to minimize dust getting in. I've been working away installing all the head studs on one side of the engine so far. And if you're going through this process, I'd highly recommend this great tool resource. Used tools on eBay. This is a set of head stud pullers or inserters, and the way it works is it comes with a series of collets, and you choose the collet you need, and you can thread that on to the head stud. So it just threads in just like a normal collet, normal thread. And then what's cool about this is you put this collet sleeve on, and there's a keyway here and a little key that aligns. And as you tighten this nut on the back, it draws the collet inside the sleeve. And if you tighten it down, you can tighten down with a wrench or 2 wrenches between this big hex and the small one. It gives you a really firm grip on the head stud. Now, why this is important is that these studs, these are made by ARP. These studs you only want to hand tighten going into the block. You don't really want to torque them down a lot. And I'm not able to get a good enough grip on them with my hand, even with clean threads. I've gone through with a thread chaser on all these holes. Even with clean threads, I can't get it all the way in all the time. And so this gives you just a little bit bigger radius to apply a little bit more torque, still by hand, in order to seat all the head studs. The other thing I've done is, after I seat each stud, just again hand tight, I have a caliper set up for about 140 millimeters, which seems to be the full seat depth. And so I can measure that from the face of where the cylinder is going to sit to the end of the stud, and all of them work out to be about the same. And that's a good gut check to make sure they haven't gone either too far in or sticking out and will look kind of weird once I bolt the head on. The last thing that I have found important is I have used Loctite 271 for each of the head studs. And ARP says you can use it, but you don't have to. For me, because I don't want these studs to come out, and because the whole reason this engine stopped working well and started leaking oil is because of the studs loosening, I don't want to go through that again. So I thought I'd go ahead and use Loctite. And if I ever do have to take these out again, I have my kit with stud extractors. This kit cost about a third of what it would be new by buying it on eBay. I think I paid about 250 bucks, and like they're about 750 bucks if you buy them new from Snap-on. And what's good about used tools is that tools like this never wear out. You can use them for hundreds of years and they'll just always work great. There's no big stress or wear on something like this. So I think there's no drawback on buying tools like this, and I'd highly recommend it. You'll get a good deal. All right, here's the process of putting in the stud. I start with my collet and the stud extractor inserter. So I screw the stud in first, and I've just been hand tightening it to start with. Then I clean it off with some rubbing alcohol, just to get any gunk off the end of the stud that's going to thread into the block. I've cleaned all the holes in the block, and even before I cleaned them yesterday, but even before today I blew them out with some air. So that's pretty clean. Then I add some Loctite 271, the red kind, and I've been doing it about halfway up the stud, and so it covers about half the diameter of the stud because it gets pushed out as it threads in. And then I'm going to put it in the 4th stud hole for this cylinder. So you can just hand thread it in. Again, I cleaned out all these holes with a thread chaser to get any remaining old Loctite out of the hole, and just make sure the threads are okay. And then I cleaned them out with brake clean, and then I blew them out, so they're pretty clean. And on many of these I can screw it in all the way. It looks like this one goes in all the way pretty well, but some of them take a little bit more torque that I can't do just grabbing the stud. I have to use the collet. And at this point, if I turn it more, it's just turning on the collet, it's not turning on the stud. So for the more difficult ones, I can just tighten up the collet. So now it's really clamping on the collet, and I can make sure that I'm seating the stud at the bottom. And I'm just doing it, pretty loosely hand tight, but you can feel when it bottoms out. I'm going to loosen up the collet, and it's hard not to jerk it tight when you do that. So I've been giving it just kind of one loosening and one just gentle hand tightening one more time, just so I know it's seated but not too tight. Then you can unscrew this and
unscrew a little bit more. It will release the collet, and then you can just unscrew the collet off the stud. And there's the stud. And then I can wipe up any remaining Loctite that kind of dripped out. This one's pretty good. Not much came out. You can see a little bit is on there. And then the last part is to measure if it's about 140 millimeters. And yeah, so it's about right on. So it's sticking out a little bit more than other studs. This is not actually at 140, it's at 139.43 millimeters, but it's close enough. And you don't have to be exactly at 140 because there is, you know, some room, some wiggle room in the length of the threaded length at the end of the stud. So that's it. Now I'm going to do it 8 more times and I'll be done. Okay, so it's time to put on the breather seal and the breather. What's cool about the breather seal, or not what's cool, but what to notice is that it's not just an oval. It's got this little cutout right here where you have to use this additional part of the seal to put on. Again, in the theme of making sure everything is clean, I went through and, ooh, I just saw a few little dust particles in here. Went through and made sure the seal is clean, the sealing surfaces are clean, and now I'm just getting some schmutz that seem to have fallen down into the breather tube. There's also some engine case sealant in here that's still a little wet because it's exposed to air. But that looks good, and so I'll pop this on and pop this on the breather. And notice too, this also has a sealing surface there. If you don't get that right, it can leak. And then there's 4 M6 nuts. Now remember, you have to tighten these down with the torque wrench to something like 8 foot-pounds. Otherwise it'll leak, and you don't want to over tighten it. It's funny, with sealing surfaces, if you don't tighten it enough, it'll leak. If you tighten it too much, it can leak because it can pull down too much at the bolt points there and kind of splay up at the end. So it's important to keep using your torque wrench. What I'm showing here is the thermostat. And so this is a device that bolts on to the top of the block. And when the engine gets hot, and hot enough where it needs additional cooling, this device is thermally actuated and opens up in the slot that you see in the middle of the device. That opens up and allows oil to flow to the oil coolers in the front right wheel well. This is a really clever little device that has a passive, or just a heat actuated thermal expansion actuator. I actually don't know if it's a metal or like a phase change material like a wax, but you can test it out, and Dempsey recommends this in his book, by just putting it on your stovetop and heating it up. So that's what I'm doing here. And now I've sped up the film by 5 times right now. And so you can see as it gets hot on the stovetop, it opens up, and this is mimicking thermostat opening up and sending oil to the front cooler. And then when it cools down, it cuts it off to keep the engine at a good temperature. Next up on the build is putting in the oil pressure relief pistons, which the bigger one goes in this hole right here, which is directly underneath the oil pressure switch. Here's the assembly of the oil pressure relief piston, where you have the piston here, which can go in and out of that bore, the spring, and the guide and the cap. Dempsey recommends you replace the piston and the spring. The pistons are quite expensive, and mine looked to be in pretty good shape still, so I decided not to replace those, but I did replace the spring on the recommendation of my machinist. And I also ended up replacing the caps because my caps were really corroded. You can see in here, oops, you can see in here in this bag, they're pretty knackered. I'm installing the chain ramps right now, and here are the 2 for this side of the engine. And you can see one is brownish and one is black. The brown one goes on the lower side, and I have no idea why they make it
brown. All the others are black except this one that's brown. I don't know if it has different wear properties or what. But in installing these, I've noticed there's a few tricks. So the way it goes in, you need to put it, you know, under the chain, of course, but you can kind of get it in and, oops, not drop it on the ground. Also clean these off beforehand. But you can get it in. I'll have to clean that off again. And when you put the bolt through, you can get it aligned in the holes, but it doesn't snap into this groove. So there's a groove that lines up with a snap feature right here. And you kind of have to feel it out. And what I had to do after the fact was realize that if the bolt is in the groove, let's see if I can do this with one hand. You just have kind of the tip of the bolt sticking out. So what I've found helpful is that as I'm actually screwing in the screw and inserting it, I can put a little pry bar in, and you don't want to pry against the sealing surface of the case, but this inside surface is fine to pry against. And you can just hold it in the right place, so you hold the chain ramp as the bolt goes into it, and then you can kind of feel it when it snaps in. So that's my helpful hint after screwing it up a few times. So I'm putting on the flywheel right now, and I've discovered an interesting problem that I forgot about when I tore the engine down. My tool for the flywheel bolts is too long. When I put it in, and if I put it in straight, there's not enough room to fit a torque wrench on this. And I would actually have to put an adapter on this torque wrench, so there's no way I can fit it. I played around with, you know, maybe putting an extension through the center here with a universal joint on the end. The problem is, yeah, I can plug this in, but I can't get a straight alignment on the bolt, between the tool and the bolt, which could potentially strip the little teeth that this 12-sided I guess it's like a torque tool goes into. So we need to try something else to get this in so we can torque it down correctly. I have an idea. I decided to just cut the tool. So I took about 1.5 inches off right here, and I cut this off with my just an abrasive cutoff wheel, and then ground down the edges so they have nice chamfers. A major milestone is finished, which is the complete assembly of the short block. So what I just wrapped up was installing the flywheel. And so all the bolts are torqued down now, and I've got this little flywheel tool that locks it in place. You can just make this out of any piece of metal. I just made it out of a scrap of aluminum. It's important to note, and I think Dempsey says this in his book too, that you don't want to reuse the flywheel bolts. Here's one of my old ones. And the reason is that when you torque it down to its full setting, the bolt actually stretches, and that causes some permanent deformation. So if you torqued them and untorqued them many times, you could actually fatigue the bolt a little bit and weaken it, and you don't want to break them. So they're just one-time use. So when you bolt it down, make sure it's good to go, because you don't want to have to buy a whole new set. So that's done, and then on the other side, this was really easy, just one bolt, is putting on the accessory pulley, which runs the alternator and air conditioning, if you have that. I'm taking it off my car. So there we go. There's the complete short block. It's quite satisfying to see this all together. And it still turns easily. I kind of gut check myself every once in a while that I can still, the lock's on, but it can turn quite easily, so all the lubrication with the assembly lube is working. And so next up is going to be assembling the cylinder jugs and the heads, and putting on the outer side of the engine, including connecting the pistons. So stay tuned, that'll come next.